Mr. Abbott here again. Another boring science explanations on warm fronts, stationary fronts, occluded fronts, and possibly the mid-latitude cyclonic storm system. All right, so we saw the cold front symbol. Now let's look at a warm front symbol. A warm front symbol is a line, and instead of having triangles on one side, you're going to have sort of half circles or semicircles on the other. Okay, those circles are on the side where the air mass is going to be moving. So if I'm looking for a warm front, what I would normally see is behind the warm front in a station model over here, you might have a temperature of 72. Over here ahead of the warm front, the temperature is definitely going to be cooler, so that might be 48. The winds behind the warm front may be coming from the southwest, say at 10 miles an hour or 10 knots. And over here, the winds are in a different direction. All right, so on opposite sides of the front, you have different conditions. So you've got a maritime tropical air mass pushing into a continental polar air mass. One of the things that we'll see is the precipitation in the cloud cover is usually out ahead of the warm front. It rained at and slightly behind a cold front, but here with a warm front, the rain is definitely going to be preceding or ahead of a warm front. So we'll call this city C and this city D, and we're going to make a cross section. We're going to draw from city C to city D. Here's the Earth's surface. I've got city C, which right now is in maritime tropical air, and city D is now in continental polar air. Right here is the frontal boundary. Okay, the slope of this front is quite different. With a cold front, it went up steeply, but with a warm front, it's a gradual, just overhang or increase. So at a warm front, you've got warm, moist air, which is less dense, pushing into cold and dry continental polar air, which is more dense. The warm air can't get underneath. It's not very good at displacing the cold air. So the warm air is forced to rise slowly above the cold air. So here's where the symbol is drawn on the weather map, on the surface where the two air masses meet. But most of the clouds that you get are going to be in this overhang portion of your warm front. And it's a completely different intensity of rain and even a completely different type of rain. Okay, you're going to have nimbostratus and altostratus clouds, thin little wispy cirrus clouds ahead of it, and where the rain is occurring, it's going to be like one of those gray days where the precipitation isn't very intense, but it lasts all day long. So my precipitation is ahead of my warm front, but if you recall from the last video, when you look at a cold front, you get short and heavy precipitation at the frontal boundary. Here, you're getting long, gentle precipitation in front of the actual line on your weather map. So as the front approaches, you're going to have overcast skies with gentle precipitation for an extended time period. Okay, it's going to be a really gray day. When the front hits, okay, the precipitation stops. Okay, the temperature increases. And after the passage of your warm front, okay, what you're moving into is you're moving into warm and moist air. So you tend to have the air pressure drops. Now, they don't ask very much about stationary fronts. As the name stationary implies, it's not going anywhere. This front is not moving. Now, the symbol for a stationary front is going to combine the cold front and the warm front symbols. The cold front will be on one side, the warm front will be on the other. So a stationary front is going to give you the symbols on the opposite sides. Now, this is the cold symbol, so my colder air would be behind the cold symbol, and this might be 46 degrees. My warmer air is behind the warm front symbol, so this might be 76 degrees. Now, you're going to get this type of front sort of when the winds are not moving that frontal boundary, but the winds are moving parallel to the front lines. So your weather conditions really are not going to change. We're not going to make the side view drawing of this. I've never actually seen that occur, but this would be my continental polar air. This might be my maritime tropical air. There's definitely a boundary, but the air isn't displacing each other. So what's going to happen with your forecast is your conditions will remain the same. Depending on what side of the front you're on, it's going to be either warmer or colder, but the conditions are going to stay the same until the front moves. Till the front begins to move. All right, so we've got warm fronts and cold fronts. Okay, honestly, if we looked at the speed of these, when I look back at my warm front, okay, and it says up here, warm fronts move slower than cold fronts. If I go back to my cold front, when I look at my cold front, okay, because cold air is much better at moving out the warm air, cold fronts tend to move faster, and that's sort of why we wind up eventually producing occluded fronts. So if I look at our next page, we get to an occluded front. Okay, occluded fronts form when a faster moving cold front runs into a slower moving warm front. Okay, typically we're going to see that occluded front tends to happen towards the center of our low pressure cyclonic storm systems. When you look at it, the symbol for an occluded front has the cold front and the warm front symbols on both sides of the frontal boundary. So I've got cold front and warm front. What looks a little weird is you're going to have continental polar air on one side of the front and you're going to have continental polar air on the other. What happened to the maritime tropical? Well, the only way to see that is to sort of look at the drawing three-dimensionally. So I'm going to say that this is city X and this is city Y, and we're going from X to Y. To really see what's happening there, we have to draw that side view picture of it. So we have X and Y. Here's X, here's Y. This represents the Earth's surface. We have the boundary between X and Y right here is this point. So this point represents this spot right on my weather map. Now, if I try to draw this, this is going to look like the leading edge of a cold front. So I have continental polar air, which is cold and dry, moving into a warm front. So that continental polar air, and I'm going to make this even steeper. The steeper the front on a cold front, the more severe the weather, the faster the air lifts. But I've got a really strong cold front, sort of has a bullnose shape. runs into the back of your warm front. So here's the continental polar air mass that was in the warm front. What happened to my maritime tropical air mass? The entire maritime tropical in that section gets forced aloft. So here is where the occluded front symbol would sit on your map. You've got continental polar on both sides, and the entire maritime tropical air mass has been forced aloft. So when you get an occluded front, you're going to have really heavy cloud formation, and it's going to be ahead of the warm front, ahead of the occluded front, over this section of what used to be the warm front, and also behind the occluded front. And you're going to get precipitation on both sides of the front. So when you get the forecast for an occluded front, is definitely heavy cloud formation. You get precipitation on both sides of the front. Okay, so it rains ahead of an occluded front and behind the occluded front. And because at the surface you stay in continental polar air masses, the temperatures remain cool. All right, our next film or next segment is going to be on the mid-latitude cyclonic storm system, but I need to break this up a little bit, so I hope you get warm fronts and cold fronts. Okay, where we are going to see them together would be in the classic mid-latitude low-pressure cyclonic storm system. Hope that helped.